Hello, welcome to SS Mathematics classes again. In our last lecture, that is in lecture 5 on indefinite integral, class 12, I discussed on some problems, all of which was about some different types I discussed in lecture 4. Now, in this lecture, that is in lecture 5, I will solve some more problems of all the types I discussed in lecture 4. Okay, let's see. Okay, now we start with this problem from short answer type category from SN book. It is actually in question number 9, but I am giving my own serial 1 dx integration dx by x root over of 1 plus x cube. See, this is the integral, and you have to apply a suitable substitution to bring this integral into one of the standard form I discussed earlier. Okay, so let's see what can you substitute. First, multiply numerator and denominator by x square, because once you get root over of 1 plus x cube as z, and after taking differentials, you will be ended up on the left hand side some 3x square dx. Okay, so that's why I am multiplying numerator and denominator by x square. Next, put root over of 1 plus x cube as some new variable z, or 1 plus x cube equals to z square. Take differentials, 3x square dx. First I just said what I just said, dz. See, so x square dx is 2/3 z dz by what is x square? What is x cube? Z square minus 1. So just put x cube, z square minus 1, and root over of 1 plus cube is 1 plus x cube as z. So this z will cancel out. 2 by 3 integration dz by z square minus 1. Okay. And see, this integral is exactly in a standard integral form, which we very know well that this is 1 by 2a, here a is 1, log mod z minus 1 by z plus 1 plus c, constant of integration. This is 1/3 log mod, what is z? Square root of 1 plus x cube minus 1 by square root of 1 plus x cube plus 1 plus c, and this is the end of the integral. Next, we take this example, integration dx over root over of 5 minus 4x minus 2x square. and this integral you have to manipulate this integral in some way that you get something like this integration dx over root over of s square minus x square. So you have to bring this style from this integral. Okay, see how can you do that? First, take these two out. That is 1 by root 2 integration dx by root over of 5 minus 2 minus 2x minus x square. Okay. Okay, I am removing the upper part. Next, 1 by root 2 integration dx over root over of 5 minus 2 plus 1 minus 1. I adjust plus 1 here, minus 1 here. Okay, minus 2x minus x square. And if you take minus common from these three terms, this will be something like this. Okay, so 1 by root 2 integration dx over root over of, this is 7 by 2 minus x plus 1 whole square. And you can write 7 by 2 as root over of 7 by 2 whole square. Now, see, this is in this form, is not it? Just you have to take a suitable substitution. Now let x plus 1 as u, then dx will be du, and this will be 1 by root 2 integration du over root over of root 7 by 2 whole square minus u square. That is equals to, what is the formula? Sine inverse x over a plus c. I did not mention plus c there. So this will be sine inverse of u over root over of 7 by 2 plus c. That is 1 by root 2 sine inverse. So what is u? You take u as x plus 1. So this is root over of 2 by 7 into x plus 1 plus c. Here is the end of the integral. Okay. So after seeing the problem, you have to think about which form you are going to establish. You are going to convert the given integral. So you have to think that which form you are going to next. Okay, I hope you noted it well. I am removing this part. Next, I take this problem. integration 2 to the power x dx over root over of 4 to the power x plus 2 to the power x plus 2. Sorry, this is minus of 2 to the power x plus 2 plus 5. Okay. First note it down. Next I am starting. See, this is your problem. Okay. I can write this as 2 to the power x dx over root over of 2 to the power x whole square minus 2 into 2 to the power x plus 2. Is not it? Just I applied the simple laws of indices. Next, put 2 to the power x as some new variable z. Take differentials. 2 to the power x log 2 base e dx will be dz. So this will be 1 by log 2 base e 2 to the power x dx, exactly what the numerator is here. So this will be dz by root over of z square minus 2z plus 5. See, if you closely look at these, you can understand you are going to get some integral like this, root over x square plus minus s square. You are going to get some integral like this. Okay. See whether we get plus sign here or minus. See, integration dz over root over of z square minus 2z plus 1 plus 2 square. Okay, we got plus sign here. 1 over log 2 base e integration dz over root over of z minus 1 whole square plus 2 square. Just again, you have to substitute one thing. Put z minus 1 as some new variable u, then dz will be du. Okay. This is first I substituted 2 to the power x as z, and next I substituted z minus 1 as u. So in this problem I substitute 2 times. Next, okay, I am removing first 2 lines. See, this will be 1 by log 2 is e integral du upon u square plus 2 square, and this is a standard integral. 1 by log 2 base e, and this is log mod u plus root over of u square plus 2 square. See here. Okay. Next. Okay. Next, you have to bring back the original variable, which is x. What is u? U is z minus 1. So put z minus 1 here plus root over of z minus 1 whole square plus 2 square, which is z minus 1 whole square plus 2 square. C equals to 1 by log 2 AC logarithm of z means 2 to the power x minus 1 plus root over, and this will be z square minus 2z plus 5 after all calculations, and this is the last line of our solution. 2 to the power x minus 1 plus 2 to the power of, see, z is 2 to the power x, so z square will be 2 to the power x whole square, something 4 to the power x minus 2 into 2 to the power x, that is 2 to the power x plus 1. That is I am writing in original form. Yes, that's C answer. This is the end of the integral. So note it down first. So all the time we see we are falling under some standard integrals. What I told you in lecture 5. 1, 2, 3, 4, 5. 5 standard integrals were there. I I discussed in lecture 5. So all the time we are falling under all that standard forms. Next, we take another example. First note it. Okay. Hope you noted it well. Next, we take another problem. Okay. Problem number 4. Integration dx over root over of x minus alpha into x minus beta. It is a very nice integral. In this type of integral, you see two factors are there, x minus alpha and x minus beta. In this type of integrals, there is no need to multiply all these things. Okay, do not multiply this. Instead, just put x minus alpha as some root over of x minus alpha, some new variable z. Because if you see, this is nothing but root over of x minus alpha into root over of x minus beta. So I just take root over x minus alpha as z, that is x minus alpha equals to z square. Taking differentials, 2z dz. Okay, so dx is 2z dz. Root over of x minus alpha is z, and root over of what is x? X is z square plus alpha. X is z square plus alpha minus beta. Okay, z cancel out, and 2, take 2 out of the integral because 2 is constant. Z by root over of z square plus root over of alpha minus beta whole square, only when you can write this thing only when alpha greater than beta. Because if alpha greater than beta, only then alpha minus beta is positive, and only then you can take root over of alpha minus beta. Because you cannot take root over square root of any negative number, because I told you in lecture 5, that is, we are not doing here the calculus of complex quantities. All that we do in higher mathematics, complex analysis. Anyway, so this is exactly in the form standard integral dx by root over of x square plus a square. Okay, so this is 2 log, what is the result? Log mod z plus root over of z square plus root over of x minus alpha, root over alpha minus beta whole square. plus c. 2 log mod, what is that? Root over of x minus alpha plus. This will be, see, this comes from here. This is exactly equal to this, and this is exactly, this thing comes from here, and this comes from root over of x minus beta. Just back substitute all these things, and you may write here, instead of calculating all these things, root over of x minus beta. This is the end of the integral. Okay. All these are in short answer type question in your SND book. Okay, next we are passing into long answer type 5 marks questions from SND book. Long answer type question. First, this is my own serial number. Actually, the problem I am going to take is in question number 2 in long answer type section in SND group. Anyway, root over of 2x plus 3 over 2x plus 3 integration 2x plus 3 over x square plus 4x plus 5 dx. So this is your integral. This is of this type, lx plus m dx by root over of ax square plus bx plus c. I think all these types, all these categories of integral I discussed in my lecture 4. For this type of integrals, you may write the numerator lx plus m as some constant k into ddx of the quadratic expression under radical sign in the denominator plus another constant k2. You can approach this method, or in this method I discussed in lecture 4. In this method, after writing this, after differentiating this, after comparing the coefficients from both sides, finally you have to find k1 and k2. Next, after finding k1, k2, you have to put k1, k2 here and put all these things in the numerator, and then you have to put the integral and etc, etc, etc. Otherwise, there is another way, there is a shortcut way which I am going to show for this problem. See, actually the problem is in this form, but instead of taking this path, we are taking a shortcut path. See, what will be the expression? If you differentiate this thing, this quadratic expression, you will get 2x plus 4. Okay, first write 2x plus 4. Because plus 3 is there, you have to adjust the constant. See, 4 minus 1 is plus 3. Okay. So first we differentiate the quadratic expression under radical sign. In the denominator we see we get 2x plus 4. That is why I write 2x plus 4, and then I adjust minus 1 because in the numerator it is originally 2x plus 3. Okay. I hope you understand these things. 2x plus 4 dx over root over of x square plus 4x plus 5 minus integration. In this line, I am parting the integral into 2 root over of x square plus 4x plus 5. So this is your first part, this is your second part. For the first part, okay, just take root over of x square plus 4x plus 5 as some new variable z, or x square plus 4x plus 5 equals to z square. Then take differentials, 2x plus 4 dx will be 2z dz. Okay? See, exactly the numerator has come here. So, you can write 2x plus 4 dx in place of 2x plus 4 dx, 2z dz by this thing is z. Okay, z cancel out. It is 2 integration dz. It is 2z. Don't put any constant here because you get one constant, you get another constant, and at the end you have to write a single constant. That is why I am not mentioning different constants for different for these two integrals. Instead of that, I will write a single constant at the end. Okay, that is 2 root over of what is z, x square plus 4x plus 5. This is the first part. Okay, and the second part. See the second part. The second part, that means this part, integration dx over root over of x square plus 4x plus 5. I think this type of integral, I think I have already discussed about this type of integral. Integration dx over root over of, this will be x plus 4. So you will get this type of thing. So this will be log mod x plus 2 plus root over of x plus 2 whole square plus 1 square. It is log mod x plus 2 plus root over of x square plus 4x plus 5. This is the second part. Therefore, the complete answer of the given integral will be this minus this. Okay? So the complete answer therefore the integral I equals to the first part 2 root over of x square plus 4x plus 5, okay, minus log x plus 2. So without adopting this method, the conventional method, I adopt alternative method here. X plus 2 plus root over of x square plus 4x plus 5. Okay? This is the end of the integral. Actually, here I write I, but I did not take the given integral as I. I had to take the given integral as I. But in this type of problems, always when the integral is something bigger in size, always take I. Okay, so this is the end of the problem. Okay. Next, I take another example of this type. Problem number 2 in long answer type question. Integration 2x dx over root over of 1 minus x square minus x4. This is your problem. See, first thing you see, if you take x square as some new variable u or z or v and take differentials on both sides, you will get 2x dx on the left hand side. What is exactly in the numerator in this integral? So first 2x dx root over of 1 minus x square whole square, and put x square equals to u, then 2x dx will be du, and this will be du over root over of 1 minus u square. Next, this is the usual form. We have already encountered this type of integrals. Du by root over of 1 minus 1 plus 1 by 4 minus 1 by 4 minus 2 into half into u minus u square. Okay, if we take common minus, if we take minus common from these three terms, you will get these things. See, okay, hope you noted it well. Next, integration du over root over of, this is 4 plus 1 5, you may write root 5 by 2 whole square minus u plus half whole square. See, this is exactly in the form integration dx by root over of a square minus x square. That is the standard integral in our serial number 5. Okay, so this will be sine inverse. This will be sine inverse u plus half by root over of 5 by 2 plus c. Okay. So this will be sine inverse of, just multiply numerator and denominator by 2, 2u plus 1 by root 5 plus c constant of integration, that is sine inverse of, what is u? U is x square, 2x square plus 1 by root 5 plus c. This is the end of the integral. Okay. And the last but not the least, problem number 5, integration dx by 2x plus 3 root over of x plus 5. Remember, I discussed about this type of integral in our lecture 4 under the form x plus b, something like that, root over of cx plus d. And for this type of integral, you have to substitute the necessary substitution. I told you that root over of cx plus d equals to some new variable u. So let us take, according to that rule, root over of x plus 5 as some new variable v, or x plus 5 equals to v square. Then take differentials on both sides, dx equals to 2v dv. Okay? So now we are dealing with this kind of integral. This kind of integral. So 2x is 2v dv. So this will become then 2v dv in the numerator. And see what is x. If you find the value of x from the second line, you will get v square minus 5. Okay? So just put x as v square minus 5. 2 into v square minus 5. Okay? 2 into v square minus 5 plus 3. And this root over of x plus 5 as v. So v we cancel out from both sides. 2 integration dv by, this is 2v square minus 10 plus 3 plus 7, I think. Oh, sorry, is minus 7. See. Okay? Okay. Next, take common 2 out, and these 2 will be cancelled out with these 2. Integration du over v square minus root 7 by 2 whole square. So we actually fall under the form standard integral integration dx by x square minus a square. What was the result? The result was 1 by 2a log mod x minus a upon x plus a. That was the result. So we actually fall under that type of standard integral after substituting root over of x plus 5 as v. See. Okay? Hope you understood well. Now I am wiping this part out. Okay. So this is v. So see that standard integral 1 by 2. What is it? Here is root over of 7 by 2. Root over of 7 by 2. Root over of 7 by 2 log mod v minus root over of 7 by 2 divided by v plus root over of 7 by 2 plus c. And this will be root over of 14 log mod root 2 into v minus root 7 by root 2 into v plus root 7 plus c. Okay. Just put the value of b, which is root over of x plus 5 here, and get the complete answer. So 1 over root 14 log mod. So this is v, this is your v, root over of x plus 5. After multiplying with root 2, it will be root over of 2x plus 10 minus root 7 by root over of 2x plus 10 plus root 7 plus c. This is the end of the integral. Okay? So for this lecture. That is lecture number 6. In our next lecture, I will do some more problems on indefinite integral method of substitution. So hope you understood well all these things, and subscribe my channel, Lessons Mathematics Classes for Juniors. Thank you.